Hello everyone, I'm back again with a new video mainly focusing on data manipulation using tidyverse package. So from the tidyverse package set we'll use the dplyr one, which is mainly appropriate package for data manipulation, data cleaning, renaming column, and missing value handling. So a lot we will cover. So before I just jump in today's session, I'll give you some tips. If you type in the console ls with bracket, it will give you lists of active data in the environment file. And if you want to clean everything, including the active environment, if you type remove list with ls double bracket and enter, your active environment will be clear. And if you want to clean the console as well, Control plus L. So we have very clean. When we talk about data cleaning, we are assuming we have the data in different format. That format might be the data stored in spaces, the data stored in Excel, the data stored in Stata, the data stored in RareCap. Make sure in which format your data is saved. Then you'll just decide which package you are gonna to use to read that data. So I have the data in Excel file, so I will load appropriate packages. If you haven't installed, before you load your package, install your package. So read Excel package is the package I will be using to read Excel files, and the janitor package is for column cleaning. Tidyverse has a set of package. One is dplyr, so I can load dplyr by itself, or a set of packages with other I can load tidyverse. I'm reading read Excel, janitor, tidyverse, and dplyr. So this is a package that I will be using for this tutorial session. My file is saved in this path, so I will call Excel file, and the data I have is stored in Excel, but in a way that has multiple sheets. So if I can open and show you how the data looks like. So this is the data I have. The sheet names are the years. So I'm reading 3 sheets in one, or you can read all each sheet separately. So I'm reading the sheets all together here and give the name leprosy, then clean the name. So already the leprosy data is in my active environment. So first thing is first, if you are working like in the big data, you need to have a backup for your data. So I just have a backup by saying leprosy copy, assigning the leprosy data. So all my exercise will be only leprosy, using leprosy copy data. In the data analysis, make sure you are familiar with your data, what the columns you have, how many rows you have, and how many columns you have. So I'm gonna to explore the data. I assign the data I read in read Excel, which is assuming the class of the data will be data frame, which means the values are sorted in a row and the columns are in a column, the variables are in a column. So I will check class. So it is a data frame, which is good. To check the attributes of the data, which means the row by data type with column name, I use the glimpse function from the tidyverse package. If I check here, as you can see, the rows I have and the column I have, and all this column list is in the data frame. So you can see this $sign is telling us this is a variable, and these all are the data type, which means the data I have is as numeric as well as character. If I want to see the first row, I will use this double bracket by using literacy, the data frame name, and mentioning 1 is the first row and all column, which if I click, I can see the first row. And if you want to see separately, we already see the number of column we have, but if you want how the columns are sorted, you can use names or either variable names. You can see this number is telling you our variable name with the order of each variable. So if I want to call by order the number of variable from leprosy dataset, I can type the data frame, which is leprosy data. And if I want to call column 12, it will give me exactly column 12 is MB mail. As you can see, here is MB mail. So we can slice the columns by position. The second session that we'll cover today is about the null value, which is, we call it missing value. Make sure your data is complete, that has no any missing value. If you are using the survey data, or if you are collecting data from the hospital records, make sure that missings are really missing. If that missings are not really missing, which means if it is a recording problem, you will find the missing handling mechanism. The missing handling mechanism, there are different mechanisms: missing by random, missing not at random, and there are different techniques of missing handling for each missing values. So how we are identifying the missing value? Missing value in R is identified or labeled as NA. So if you want to see the number of missing by row from the data frame, you will use the sum function, and is NA in R is already NA in the data frame. So give me the row numbers of missing value by sum each from the leprosy database. So if I can see, I have 205 missing rows, and if you want to check each column, you will have pretty much outcome variable which shouldn't be missing, or you might have the exposure variable, which is important for your analysis, that has missing value, but you need to handle that by substituting the mean or the median or any other missing handling mechanism. So I just wanted to the column level missing numbers. For example, my data is collected at district level. Make sure the district is has no any complete value. As you can see, the summary is not NA, which or is NA is giving me. If there is false, which means there is missing. As you can see, the number of health facility, I have 12 missing rows, which is that I need to figure it out. And I have important variable, which is Warada, all complete, which means I have no any false. So this is a way that you can check which important variable is missing and which has no any missing value. And if you identify at district level, which I don't have any missing value in Warada. If I just substitute something, do I have missing value in year, which is I can type year. I don't have. That's the most important variable that I need. Do I have the missing value for any one of the outcome? Maybe there are two types of leprosy data. The data I'm using is leprosy data. So if there is any missing value in that outcome, you will manage it. So this is how you will identify NA values from your data set. So let's jump in the dplyr package, which is one set of tidyverse mainly used for data manipulation technique. So in this dplyr package, we will cover how we select column from the dataset, and if you have very long column that you need to shorten that, we will cover how we will rename that, how we filter rows for a single column or a multiple columns, and sometimes the data would have a duplicate rows, how we can filter only the unique rows from that data. We will cover that by distinct function. Arrange, you can arrange the row ascending or descending, and if you want to move the locations of the column, we will cover by relocate. And in R, you can create a new variable using the existing variable by using mutate function, or you can alter the existing column by substituting the number. For example, if you have NA value, if you have 0, without modifying the column variable, just substitute the value that I have with the new variable that we can use mutate. So if I go, the first one is, what is pipe? So pipe is one logical operator in R that will help us to chain the lines of the commands. So when we are writing a function, for example from the select function in tidyverse, pretty much applying the pipe one. Select function is a function that will help us to pick a specific variable from a data frame based on our selection criteria. We might pick all the data that start with number, or we can select only geographical data, which means the district name, region, or any lost administrative geographical level. So from this, what I am doing is select from the data frame leprosy copy only woreda and year. If I select this, it will give me two columns, as you see, woreda and year. And instead of writing this, we can write in a name, like first I will call the data frame, which is the leprosy copy. Then I will use the same function, which is select. Then from select, I will pass the district or the woreda year. I will get the same result here, woreda and year. Pipe operator, when we are writing a set of multiple command line that will help us to chain each by one, that makes like easy, readable, and understandable. So that's how the pipe operator is using. So the select function in tidyverse, in the dplyr one, it can help us to select important variables that we need to include, or it will help us the variable that we don't need to use. So if I wanted to remove the variable, the sheet name, number of fields, facility, I will put the minus sign with the select function in front of each variable. Then if I just create a new data frame by selecting or removing these two and check the data 2, I don't have sheet name as well as number of facility, but in the leprosy I have sheet name and a number of fields facility. So this is how you can select and remove one by one. Or if you remove multiple variables, you can use the minus sign in front of the C, which is combine, then remove that column at once. So I don't have here sheet name and number of files facility. I remove by combining or by putting the minus sign in front of each column name. So the message in the select function is select function used for column selection to subset the variable that we need for our analysis or remove the variable that we don't need for our analysis. Okay, as you can see, the column name is very long. To make the column name more readable, I will gonna to rename each column. So in the datasets, as you can see, if I click the dataset here, as you can see, for example, the total number of new case detected, it can be shortened, say, total number. And this is the leprosy data. And this leprosy data has two types of leprosy. I will let you to explore what's PB and MB, but it has PB type with a sex male and age less than 15 years. So we need to separate this and give a meaningful name. For that, the dplyr package have a rename function, but the rename function is working. If you see the help of rename, how rename function is working, you need to pass the new name equal to the old name. So from this data set, the number of health facilities old name and health facilities new name. So what I've done here is rename the number of health facility with num health, total number of new leprosy cases detected with total cases, male less than 15 with male, female PB, female less than by female. So what I've done here is I rename and combine by the pipe operator and select the new I have created. So if I click this, I will get number of falsity, total cases, male and female. So as you can see, the rename function will help us to make the variable name shorten and as well as make it readable and clear. How you can subset variables using the start with and end with as well as contents function. So from the leprosy copy data here, I can select a column, which means start with. As you can see, I have the column, which is two column that started with PB, male less than, and PB, male greater than. And there are two more columns, so it should be female, PB female, and greater than and less than. So it has totally 4. What if I want to select by end with? So I can start, rather than like, if you want to make sure everything is captured, you can use the short way of, if I have end with years, if I can pass select end with underscore years, I have less than 15 years, greater than 15 years, and I have 6 more, which means female less than years. So if you check all end by years, I can just pass the end with function. Instead of using select and list of all, I can pass the function contents from the tidyverse that has male. See, as you can see, I have a lot of columns that contains males, which means pretty much 12. So I have 12 here, and the other 10 are listed here. So you can just select by passing the abbreviation that is already in the column name. So let's go to filter, which is picking the number of rows or the rows with a certain criteria. So if I go number of files facility that has greater than 1000, I will say from the literacy data, number of files facility greater than 1000. If you click here, it will give you, I have 30 rows that has greater than 1000 number of files facilities. And as you can see, all of them have total. So this will tell me in our dataset, total is included as word name, which is one way of data cleaning that you need to filter out. And if I want to have the data from 2015 and 2017, just give me the data that has only 2015. So this is totally, I have 616 rows with the year 2015. So to just make sure, is my data set has NA value for number of files facility. If you remember, while we are checking before, here we found the number of files facility have 12 NAs. See, if you go up here, number of files facility have 12 NAs. So I just want to have the data that has no NA values. I will pass this exclamation mark in front of is NA. Then it will give me the number of files facility. If I check filter that has NA, it will give me the number of files facilities that have NA values. But if I pass not NA, it will give me all the health facility by excluding the null values. So from this, we see total is considered as word name. So I want to filter the data without having the word name. So I said from the data I have, filter all those that have total. So from my previous post, you can see what this operator mean. This operator mean is just that contains. So instead of this, you can use double equal sign, which has a similar use. So it's just filter all that has word name as total quarter. So you can just filter that has no this, or you can just remove by passing this. Please give me the data that has no total value in the name of word name. So this is how filter function is working. The next one is the distinct function, which means if your data set has duplicate rows, you can just pass the distinct function to get the unique value. So I pass the data, which is the literacy copy, select worda. Please give me distinct by keeping all rows. So I got 169, which is 10 of here from the data I have. But I make sure filtering the data that doesn't capture literacy copy. So I will assign, give me the data that has no total in the word name. I will pass this again with literacy copy. So I will have a literacy copy that has no total in the word name. So I just check again the distinct one. I should have nearly 168. So you can count the number of district is similar by passing the count one. Just I have 169 distinct words in the data, but I have 3 years data, so this multiplied by 3 will be my number of row in and it is by quarter as well. So you can imagine how many times each Warada is duplicated in the data. The next one is arrange, which arrange is helping us to sort our row ascending and descending. So the default order of R is ascending. So if you want to pass if you want to see sorted in descending order, you need to mention the descending. So if I just delete descending and put the arrange, it starts from year 2015. But if I want from the last year, I will pass here the descending function, then enter, it will start by 2017. So you can sort your database from from A to Z or from Z to A. From literacy data here, if I want quarter next to year and delete sheet name, so I will have year, quarter, Warada name, and number of files facility. How can I do that? I will do literacy copy select name. I just want to put the quarter and before Warada. Before Warada. So if I pass this, you can see year, quarter, Warada. So you can relocate your column name from left to right or from right to left. So instead of before, you can use just after the year. I can say before Warada or after year. As we can see, it's similar. The next one is mutate. Mutate is a function that will help us to update our variable, which means you can just change the value of a single column by giving new name or without modifying the name, altering as it is. So in this function, what I'm doing is, as you can see from the data set, I have a lot of zeros. I'm not sure these zeros are real zeros, so I want to substitute from 0 to NA. So what I have done is, from literacy, select these two columns and mutate, which means across each rows, please change NA value to 0. So this doesn't work if the selected columns are only numeric, but they are numeric, so all zeros have changed to NA. If I check view, which means you can see all zeros are NA. One thing that you need to be aware that if you are doing your analysis, a big data set, this across function will make everything is changed. When you are just altering the value of the column that you have, make sure that zeros are really 0, or you need to substitute that with certain value. If you want to just substitute everything, regardless of the data types of the columns are numeric or character, you can use the replace function here to just change everything with NA. But this one is everything NA if will help only for numeric one. If I do this and see everything has changed, I will pass the view. Again, it will give me all the data set have converted regardless of their numeric or character. But the important thing here is the mutate function without changing the column name, you can just update it. But what if you have if you want to create a new column, I will use from the dplyr summing the pb from the dplyr copy mutate pb is equal to, I have pb male plus pb female, which is pb less than 15 years and female less than 15 years. If I click this, let me select only, select word, year, and the new what I have created. So as you can see, this is how you can use the mutate one. If I can see all the data, what I have done is just I summed up PB less than 15 years male and female. So this is how mutate will work to alter the existing variable as well as to create a new column name using the existing columns. The next one is how we subset the data, which means from the dplyr data, I have the data for less than 15 years, I have the data for greater than 15 years, and I have the data for male and female. So if I want to subset by year and types of dplyr, PB and MB, so what I have done here is subset only under 15. From the data frame, I have dplyr copy. I create a new data called PB under 15, rename PB male less than 15 and female less than 15 female, and select with year and word by quarter. So I will have the PP under 15. If I click and see, this has renamed and contain only PB1. Here I'm subsetting under 15 PB cases by sex, male and female, but I don't have the types of diabetics as well as age information, as you can see from this. What I will do is I will assign the type column name and give the row PB for all, and I will assign again age column and give it less than 50. What I have done here is I pass type and age column by specifying the age group and the types of PB. Why I'm doing this? Because I know from the column here is PB and age less than 15. So I have added this one. As you can see here, I have the data frame with all the information. So I will do the same for all, for MB as well, and I just will continue for the next one. So as you can see, I have this, I have this. So I want to show you how can I combine this. I have PB under 15 and PB above 15 separately. They have the same column name and they have the same districts, the same year. So it should be bind in row. So how can I bind in row? I will use row bind function and give the variable name is PB. If you go PB here, this PB, just press filter, and if you type here MB, there is no MB, but if you type here greater than 15, you can see there is greater than 15, and if you type here, if I pass this one, the type, that's only one. If I pass this the year, can you see 2015, 2017, the quarter, it should be all quarter, quarter 2, quarter 3, and quarter 4. Excellent. So you can bind in a row both MB and PB. So this row bind function will work only for 2 database, but if you have more than 2 data frame, you can use the bind rows function from the dplyr. So I pass all PB and all MB with under 5 and over 5 just by giving PBMB bind row. If you can see PBMB database, I have everything here. Again, if I filter male, female, type, I can say MB. Yes, it's already here. And ages, obviously, it will be combined. So this is how you merge two data frame in a row. And there is cbind, which is combining in a row, and cbind, which is combining by column, and bind column function from dplyr as well. There is grouping function that will help you summarize the database by certain criteria. For example, if you want to see the case by sex or by age group, so there is a group by function. Give me the female and male group by year, types of leprosy and age group, because as you can see here, we have year, 3 years, and male, female, type, but male, females are a column. This is a wide data format that need to be male and female under the sex column. We will see that. But type, so I'm covering here group by male is equal to the sum of male, female is equal to the sum of female. And the reason why I'm using NA remove true is if there is NA value for each column, the sum function doesn't work. If I just delete this, and if I have NA, this function, this is not working, but I don't have NA, so I got you here PB grouping, so I can see grouped MBBP here, grouped by year. I don't have any quarter here because I have grouped by year, age, male and female. So I will use this data to convert male and female as a row, not as a column. That is, we call it the reshaping technique in the tidyr package of tidyverse. If I check, there is in the grouped data, is there Warada that has quarter name? So give me the data that has no total quarter in as a Warada name. If you check first this one, this group PMD is 1912, but if I remove them, I will have 1900 because this 4 quarter for 3 years has removed. Okay, from this database, what I will do is I will assign male and female as a row with the variable name sex, that you call it data reshaping. So reshaping the data is an important part when you have a wide data format for analysis in long format. If you do time series analysis, means as a column name that need to be in a long format to see the trend, that you call it pivot longer. And if you have a wide format, a longer format to see the data in using value as a column, you will change that wide format. So for today's session, we have a wide format data, which is male and female as a column. I will change to a long format. You can see how this is working. There is a pivot longer function. If I put a question mark here, it will give you how this function is working. It's searching here. So this is from the dplyr function here, from the dplyr package. Pivot longer, you'll pass the data column, so names to name and values to value. So from this function, what I will do is male and female were a column that I want to convert. So give the male and female names as sex, and the value from male and female give it as cases. So I'm expecting male and female as 0, but the value they have here, will be cases for each corresponding row. So if I give the name long format and enter, if I click here, I can see sex as a column with the value male corresponding cases are 0. So you can change multiple columns by using, there is a technique that you need to follow, advanced technique, by giving name prefix and this combination, the pattern combination. So that is like when you have very complicated one, you can just explore the documentation how you change in the long and wide format. So the last session is joining technique. So if I go to my recent posts on this code documentation, as you can see, I have the data frame test and positive, and I want to join them by primary key. So from this data set, my primary key is year. Both of the data frame has year. So, but one data, the test data has from 2015 to 2020, and the positive data has from 2013 to 2018. So I want to join this database, this data frame. I want to join this data frame by their primary key, which is year, for my analysis. So there are 4 joining technique. One is the left join, which means it depends on which you pass as a left, test or positive. For my case, I'm passing test as left table, keep all the rows from the left side, and join with a positive. So if I say I can expect the right table, which is a positive column, has no value for 2019 and 2020, because I have the data from 2015 to 2020, so it captures all the data that has in the left. That's why it has NA value. If I want to say use inner join, the inner join is bring all the rows that have common into data frame. So the 2 data frame has from 2015 to 2018. So I will keep all the rows that have common in both. And the third one is right join. As I mentioned, I pass test as a left. I said right join, type right join test comma positive. It will give me all the rows that is in the right table with the null value in the left one. So I have the data from 2013 to 2018. So all the rows from test data that has no 2013 and 14 will be NA, but in the right side it will be the completed. The last one is the full join. Regardless of how the data, please give me the combined table. So I am expecting the table from 2013 to 2020. So it has all the data with NA value that has no in the test, NA value that has no in the positive. The last one is the anti-join technique. This anti-join will give us the data that has no in common. Anti-join XY. So Y database has no 2019 and 2020. So if I pass anti-join positive test, again I will get 2013 and 14. So let's practice this in the database. So I have created, let's practice this in the data frame. So let's create a data frame called test that has year and tested, and positive that has year and positive. As you can see, we have two data frame with year and positive and test and positive, but the year is different. So we are taking the primary key, which is the key that you will going to join to data frame is year. So if I pass test first and inner join, it will give me the join of the common that has in both. So if I say view to see while we are doing, so it gives us the two data frame that has in common from 2015 to 2018. If I pass here left test and positive, it will give me only the value that's in the test with null with NA. The right, again, the reverse is true. The test will be NA and the positive will be there. And if I want to see the full join, regardless of the having common, it will give me the full database. But if there is no in the positive, it will be null. If there is no in the test, it will be null. Anti-join test positive, it will give me only the database that has in test but not in positive, which means 2019 and 2020. But if I put positive first and test next, it will give me 2013 and 14. So keep in mind that the positions of the data frame that you pass depending to pick which rows are not in common. So finally, you have all clean database, and if you want to save that, probably if you want to do your analysis in Stata but the management in R, you will use the write function, the write followed by the format that you want to save. I want to save the data in CSV function, which is, I wanted to save the data in CSV format. I pass write CSV, which means I pass the data that I want to save and where I want to save with the name CSV in R format .rds in Stata format .dta. So this is how you'll save your clean data frame in different format. I'll see you in the next session. Thank you for watching.